name is McCavour. I'm working on this project with a few different people. I'll go over that in a second. But we're looking to develop a forest soil health and assessment framework for the province. And so we're calling it ForestSHARE. So if you get anything out of today, hopefully we can remember that acronym. And we're specifically targeting private woodlot owners in Nova Scotia. And so I'll talk a little bit more about that. But I just want to introduce myself because I know a lot of people won't know me. So my name is Caitlin. I'm currently a PhD student at the Dalhousie Agriculture campus. But for the last 3 years, I've worked as the soil extension person for agriculture for the province. And then before that, I worked on some forest soil research projects. Most notably is the Otter Ponds Liming Forestry project. And so my overlap of where I'm trying to develop my expertise is in soil science as well as extension. So this project really fit what I was trying to do. And so I'm really excited about this project. Originally, I didn't really want to go back to school, but I think that for this project, it's worth it, and I hope that other people agree. So before I get into what the project actually is, I just want to talk about our project partners. So we have a lot of project partners, and the things that I'm working on specifically, I'll talk about that as well as some of the larger goals of the project that some of these other partners will be working with. So our first partner is Murray Reeves A Forestry. So that's Debbie Reeves, if anybody's familiar with that name. She's worked in forestry and her family's been in forestry for a really long time. So she's an accountant by trade, so she's doing the accounting piece of it, but she's also a large connection with private woodlot owners through the province. We're working with Dr. Kevin Keys, who's with the Family Forest Network, previously was with the Department of Natural Resources, and then also with a couple different labs at Dalhousie. So I'm part of the Center for Sustainable Soil Management with David Burton. And then there is a soil microbiology piece to this project out of Halifax. In addition, we're working with NSCC, the Department of Natural Resources, as well as Genome Atlantic. So there's a big group of people that are working on this project. And so as I go along, please feel free to interrupt me at any point if you have any questions. Like I said, this is a little bit more discussion-based because it's a smaller room. If there's something that you're unclear about or want to know more about, because this is a very surface-level overview of the project, please just interrupt me.
Well, I am going to interrupt you then just from the beginning. Soil extension.
Yes.
What is it?
Yeah, so extension is basically knowledge translation. And so in terms of agriculture, how we define soil extension is that you can take soil samples, they'll be delivered to the lab, you get those results, and you get management interpretations back. And then you also get additional information about your soil. So a lot of this will include knowledge translation about different characteristics of your soil. So right now for forestry, we don't have anything like that. We don't really know anything about the soil. We know, in general, different soil types, but we don't have any chemistry, physical, or biological analyses done on the soil. So even if you, as a woodlot owner or somebody, were to go out and take a sample, you get a bunch of numbers that mean nothing right now. And so that's what we're trying to develop the framework behind that. And so these programs, extension programs, often act as a gap between academic and research and field application. You have these people, because foresters, farmers, anybody working in the field often don't have time, and it's not their responsibility to do their own research. These extension programs are designed to fill in that gap so that they can link what research is being done to what can possibly be done on your property to improve management. Yeah, that's a great question.
Thank you for asking us.
Yeah, and yeah, there's often times where, because I've worked in extension the last 3 years, I forget that that's not, so anytime you're like, well, that's a soil term.
When you say it, the first thing I think most of us think of is, oh, we're extending the soil.
Okay.
Or we're extending the growing season of the soil, or we're extending something of the soil.
Right, yeah.
The soil.
Yeah, no, that's a great, it's the knowledge gap part that we're addressing.
And that would be sent by the owner.
Yeah.
To
Yeah, and I'll
And how
explain
is-
that
okay,
a little
as you
bit
come.
more. Yeah. So the first thing I just want to talk about is one of the primary things that we're looking at is soil health, and soil health is kind of an arbitrary term that gets used sometimes, and it's very different depending on the ecosystem. So you're going to manage land for soil health very differently in agriculture versus forestry, and even amongst a sugar maple stand versus a pine spruce stand, that soil health is going to look different because those species prefer different soil characteristics. So in general, soil health is often defined as the capacity of the soil to support living ecosystems. But it's what our goal is with this project is to characterize soil health for different forest types across the province, which hopefully can lead to improved soil health, which can lead to increased forest productivity, carbon sequestration, biodiversity, climate change resilience, all that good stuff. So the impacts of this project I really like to think of on two scales. So one is the Woodlot scale. So at the end, we're developing this database of soil information so that a woodlot owner will be able to take a sample, submit it to the lab, and then know where their soil properties line up against other similar ecosystems in the province, and then potentially have management implications associated with that. And I'll talk about that. That's the end goal of the project. This is a 4-year project to begin with, and likely will extend to about 6 years. And so the other thing is that if we can characterize and improve soil health, then hopefully we can achieve some of these overarching climate goals, like improving carbon sequestration and climate resilience and all of that.
So
Fun
you're
stuff.
in year 1 at this point?
Yes, we started in September. So we're very, very early stages, and we're just trying to get the word out. So the problems that we're trying to tackle is that we don't know which soil health properties are important. So when we measure soil health, there's a extremely long list of properties that you can measure, everything from pH, every single nutrient, to the texture, to the microbes, mycorrhizae, all this stuff. I think there's 40 to 50 different things you can measure, but not all of that might be important for a specific forest type in Nova Scotia. So that's the first thing we're trying to do, is identify which soil health properties are relevant to measure and also easy enough that a forest professional or a woodlot owner could go measure them themselves. The other thing is, once we identify these important properties, we don't have any values. We don't know what the range of ideal values is for these properties. So what we are doing is going to be developing a province-wide sampling program. And so I'll talk about that a little bit more. So the overall objectives is to develop a suite of forest soil health indicators. So as a woodlot owner, you'll know which indicators are important. And then develop a sampling program, and the end goal would be to have management interpretations come out of that. So I'll show you a little bit of what we're doing. So in order to do this, we have to start from the ground up. Yeah, pun intended, absolutely. And so we're taking our target of 1,700 samples across Nova Scotia, and we're trying to target a wide range of conditions. So we're looking at different ecosites, so different vegetation types, different soil types, because there likely will be vast differences between more nutrient-rich forests or more nutrient-poor, different drainage classes, all that stuff. So then we're going to use this data to develop benchmarks. So we're taking 2 samples at each site. So there's 850 sites across the province that we're targeting. We're going to be targeting a forest floor sample as well as a mineral sample.
Is there a difference between the forest floor and the mineral?
Yeah, so the characteristics would be very different. So the forest floor would be is typically kind of that 40 to 60% carbon.
That first bit?
Yeah, so it's that LFH. Let me see if I can find a soil pit picture. I'm sure there's one in here somewhere. Yeah, so if we look at this soil pit here, the forest floor is this section here. and then the mineral soil starts here.
Oh.
And so the forest floor is all your litter, so that's being slowly decomposed. So it's not there, whereas the mineral soil, we kind of look at it, there would be a mix of sand, silt, and clay. You wouldn't have that in the forest floor because it would all be carbon-based materials. Yeah. Yeah, so it's your litter fall that's being decomposed, and as you kind of go down and the soil profile gets more and more decomposed, and then you hit that mineral soil. Yeah.
So where is the carbon? Is it in that forest floor or is it down further?
So in the forest floor, typical ranges when we measure carbon would be about somewhere between 40 and 60% carbon. But the mineral soil would often maybe have like 4 to 5% carbon. So your carbon is coming from anything that is alive, dead, or very dead is the definition. That's my favorite definition in soil sciences. When you talk about organic matter. Yeah, alive. So in your mineral soil, you'd have a little bit of carbon base from if you have, some decomposition that gets like leached downwards or something, you might have a little bit of it, but it's mainly concentrated in that top bit.
So if I might ask then, so let's, for the typical Nova Scotia garden, if you will, the soil is clay, at least here in Cape Breton.
Okay.
So does that mean that there's no forest, what's that called?
Forest floor? No, so the clay, so there would still be forest floor, but the clay content is only measured in the mineral soil. So you have your forest floor, which is typically developed from things falling on it and then decomposed from microbial activity, where your mineral soil is developed from generations of soil processes. So you would have clay in this part of the soil or this part of the soil. This is a very sandy soil, so it would look a lot different than some of the ones. But you would have, how we measure texture in soil is the relative abundance of sand, silt, and clay. So if you have a clay, something with a little bit more clay, you might have 40% clay, 30% sand, 30% silt or something. But that's only measured in the mineral soil because there's no clay in the forest floor.
Okay.
Yeah.
So if you remove the forest cover, what happens to the carbon?
It decreases quite a bit. So that would be kind of like in an agricultural system if you're clearing everything. We measure, so carbon is typically measured as organic matter, which organic is just kind of another word for things that have carbon in it. And so typically, depending on the agricultural system, it'll range anywhere from 2 to 10% organic matter, and the 10% would be like in a pasture where you're not tilling and stuff. So anything you do to the system is going to decrease your carbon typically. So harvest would decrease your carbon because you're removing carbon from the system. Yeah, these are great
The carbon
questions.
that's in that layer,
Pardon?
The top layer?
the top layer, that after harvest can decrease too,
Yeah.
right?
So some of the in my garden, it's like there's like an inch or two of like grass and roots, and then it's rocks and clay.
Yeah.
So there's like everything's been removed, it's been grazed off the land over generations, right?
Yeah.
So
And organic matter has come out in a lot of studies as one of the most important soil health properties because it's kind of, when I think of soil health, a lot of times I think of your chemical properties like pH, calcium, nitrogen, phosphorus, potassium, all that stuff. Then your physical properties, which would be like your texture, your structure, and then your biological properties, which is who's living there. And the soil organic matter is kind of if you have it in like a Venn diagram, it's that middle piece because it helps with soil structure, it helps your soils like hold together, as well as it has a lot of nutrients associated with it, as well as that's where all your critters are living, that's where your bacteria is living because they need that carbon as a food source. So yeah, it's organic matter. If anything with soil health, if organic matter is a key component. We still don't know the extent of how important organic matter is in forestry in Nova Scotia, and that's something that we'll hopefully find out with this project. Yeah, so some of this. So how we're selecting the sites. So we're selecting 850 sites, but we can't do it on a volunteer basis, unfortunately, because we need the sites to cover the wide range that we want to cover, and it also needs to be statistically robust. Because on top of wanting to provide this information to woodlot owners, we are also trying to make sure that it's viable for academic research. And so what we did is we divided all of the forests, we took the predictive ecosystem mapping model, which basically predicts all the private woodland in Nova Scotia, or all woodland in Nova Scotia, what vegetation and soil type is there. And we divided that into different eco-sites. And then based on each of those eco-sites, we're collecting 30 to 90 samples. That ranges, depending, some of the eco-sites only have 800 hectares associated with them, and some of them have 85,000 hectares associated with them. So we just allocated the sampling based on how much land was there. And I think the next slide is the exciting one. So this is what it looks like. So all of these different colors represent a different ecosite, so a different vegetation and soil condition that we're targeting.
Wow, that's a lot.
Yeah, so we're sampling over 3 years, and we're actually hiring samplers to do the sampling.
Okay.
So yeah, if there's any forest professionals, and all we require them to do is to be FEC trained, so trained in the forest ecosystem classification, and then we'll have one afternoon of project-specific training. So if you know anybody who's interested, we are hiring people at $200 a site. The other thing that we have to do is, right now we have this information, and I have the names of who all these points are associated with, but we have no contact information, and that's also not information we want to just distribute widely. So if you do have a private woodlot, or if you know somebody who has a private woodlot who's interested to know if one of their points is one of the sampling points, then you can reach out to us, or come even talk to me here. I have the list. We haven't found too many yet, because there's 850 sites, which is a lot, but I think there's over 30,000 private woodlot owners in the province, so it's a little bit like a lottery, trying to find who's, and contact information. And so the first thing we're really doing is targeting, some of the sites have fallen on some of the larger landowner or private companies, so we've reached out to them. But what the hope is today is anybody who's interested in doing some of the sampling, as well as interested in to see if these points match up with their woodlot. And all that we're requiring is access to your land. We'll take a few samples using an auger. It'll be very non-invasive, and then answering a few questions such as, what have your harvest practices been in the past on that piece of land. There are a few things, like we're only targeting stands over 40 years old. We don't really want to target newly harvested lands, because we're trying to capture the actual conditions, whereas if we harvested recently, that would change the soil conditions. So we want to make sure we're capturing what the non-harvested conditions are. So and we know, we've looked at through some Google map data to make sure that they haven't fallen on harvested land, but that's depends on how recent it is too.
Or part of the land is harvested, but the other part was never harvested.
Yeah. Yes. Yeah. Yeah. So it's so we're looking, and that's why it's very early stages. We likely won't have a lot of results come out of it for a couple of years, but it's really we need to start now so that we can have this going forward.
I'm guessing you've cross-referenced with Crownland, and you've already gone to the soil types that are already accessible.
So Kevin Keys, who used to work with he's with the Family Forest Network now, but used to work for the department, and they're continuing it, initiated a program where they're doing this sampling on Crown land. They don't, so I think we have about 200 samples from Crown land right now. it's because they work on multiple projects, they're not able to kind of allocate somebody just to this. But when we're benchmarking, when we have all the data and we're benchmarking, we're incorporating that data as well. We know, yeah. And that's, you know, the more information we can get as they continuously collect information on Crown land, we'll incorporate that into the database. And really 850 sites, you know, you want to sample as much as you can, but it's a logistical and funding limitations is what it is.
But
like
the more
that's
samples, the more,
yeah.
the better, the robust the information.
Yeah, and this is just what we thought we could reasonably do within 3 years.
I see.
So this is just to kind of give you an overview of the distribution of the points. So the largest, these are the different counties. Cape Breton has 39. They're all around 30 something. I think Inverness has 59.
Richmond 35.
Yeah, and so it's all, and they're randomly selected. So we took a program, we plugged in the EcoSite, all of the mapping information for that, and then put it in a program, and it just randomly put the points throughout. And we made sure that the program that we used distributed them so that they weren't clustered.
Yeah.
So that we don't have 7 out of the 30 points within one stand. Wouldn't be that helpful, because we want to also capture different climate conditions, and you know, and management in Cape Breton is likely going to be a little different maybe than down in the southern end of the province because of climate conditions, or the soil might look differently, and these are all things we're hoping to find out. So we randomly select them. So if your site is randomly selected, you will be contacted, a sampler will contact you, but like I said, the amount of information that we need is pretty limited. There's going to be 5 or 6 questions that you need to answer, and then just A-OK that somebody comes on your land. So I'll just give you an example of one of the sites we're looking at. So this is the map. This is on the Lunenburg-Kings County line, is that yellow point there. So for example, this is site 336, and we're looking for EcoSite 14+. So we'll have 30 to 90 points within this EcoSite. We give that information to the sampler, and they're looking for these specific conditions. As long as the site matches one of these conditions, then they take the sample. So that every time we hit an EcoSite 14+, it has to be one of these conditions, so that we're kind of covering our bases on that when we make these management interpretations, they'll be EcoSite specific. So, you know, this is a sugar maple white ash stand, but the soil will likely look different there compared to a spruce pine stand. So that's why we wanted to sample them separately. Because if we just did randomly throughout the entire province, you're going to get a lot of variation, and this is to try and make sure we capture where some of that variation is coming from.
Okay, so could you explain that then? So what does EcoSite 14+ mean, and then what is TH3 and TH4?
Mm-hmm. So this is all based on the Forest Ecosystem Classification Guide. And so I think the first one came out in 2011, the forest, and basically it's a guide that forest professionals use to characterize different stands. And you go through and you, so this is the vegetation type. So there's a bunch of different vegetation type. TH stands for tolerant hardwood. So there's spruce pine, there's intolerant hardwood, there's all kinds of different forest stands, and then within each of those, there's different kind of subsets of a tolerant hardwood. So for example, this is number 3 and 4. So tolerant hardwood 3 refers to a sugar maple white ash Christmas fern stand. Tolerant hardwood 4 refers to a sugar maple white ash silvery spleenwort stand. So they'd be similar soil characteristics, likely maybe just a little bit different of vegetation type. So in addition to different, and so the FEC, the Forest Ecosystem Classification Guide, has kind of a key where you can key it. If you go into the woods, you can key out the different forest types, as well as the soil types. So these are just different, so 3L would be a soil type 3, loamy, and I don't know off the top of my head exactly which 3 is, but basically it refers to different richness and drainages in the soil. So if you have this guide, you say I'm looking for soil type 6, and you go to that page in the guide, then it'll tell you the description of what that soil type 6 should look like.
And that's that section below the organic matter, am I right? That's,
Yes.
That's primarily that
Yes.
as you say, that percentage of sand, silt, and
Yeah, and that, so things like, typically you're looking at, if you have a soil that has higher clay content, in general, typically you have poorer drainage because you have a hard time water. And a lot of times it could potentially be richer because clay is able to hold on to nutrients better than sand. So things like that. It's just a Nova Scotia-based classification system, and we're using it because the samplers that we're using are forest professionals, and they're familiar with this classification system. Does that answer your question?
You can access the guide for free online as well.
Mm-hmm. Yeah, it's open access.
Yeah, there's a new version 2022.
Yeah. So I think the original was 2011, and then and it basically there's a key. So if you go into the woods, you can key out your forest type, and then each forest type has a page that describes it and what you should find there, and the percentage of what tree, the likely percentage of finding that tree and their abundance. Like I think they continuously are sampling plots for it.
the Forest Ecosystem Classification Guide. Is that
Yes.
what it's called?
Yeah. If you Google that, Forest Ecosystem Classification Guide for Nova Scotia, it should pop right up.
If you can't find it, just email me.
Okay.
So once we collect the samples, they'll then be dropped off at a bunch of different locations. So I think this is actually one of the locations. The map's a little bit cut off here, but basically the soil has to be frozen because we don't want, after you collect samples, processes can occur in the soil, so off-gassing and stuff, but if you freeze it, it'll halt microbial activity as best as it can. So because we're trying to capture that data, so after the samples are taken, they get dropped off at these locations, and then eventually they'll get delivered to the Dalhousie lab in Truro, and then we'll do further analysis. So the things that we're looking at is pH, all of our nutrients, so calcium, magnesium, nitrogen, phosphorus, potassium. There's a list of quite a few of them that we're measuring. Texture, aggregate stability, which refers to how easily soil breaks down when external factors are put on it. So things like heavy rainfall, compaction, how well does that soil hold together? Organic matter that we talked about, carbon. So organic matter kind of gives you a general sense of all of the carbon, but then we're kind of breaking that down into different carbon pieces. So which carbon, things like that are more readily decomposed versus not. And then the microbial information. So that's being done out of a lab in Halifax. And that's an interesting piece of the project, but that piece is a little bit more of kind of like a discovery piece because we really have no idea what we're going to find there. Because the soil microbiology is a bit of a black box. We have no idea who's there and what they're doing to an extent, but they're working on that piece as well. So that's a really interesting part of the project that hopefully we'll get some good information out of. And if your site is selected, we will give you the individual information. It's just that right now it won't mean a whole lot until we get the management interpretations.
So for the microbiome information, is that stuff like mycelium that the trees are helping send signals underground through the soil?
Yeah, so
Like
what they're doing, and I don't 100% know every single measurement that they're taking,
Okay.
but they're trying to characterize the bacteria and fungi within the soil. So they're doing DNA analysis, and then hopefully, because right now with a lot of microbial measurements, sometimes we measure like soil respiration because your microbes are respiring, so you're measuring CO2 coming off of the soil. And that tells you how active microbes are being, but it's not telling you who's there. The DNA analysis can tell you who's there, but it's not telling you how active they're being, because that depends on if they have food supply. So I think they're trying a few different things to kind of understand it better. But where the research on microbiology and soil in general is further behind chemical and
absolutely.
physical analysis.
Yeah.
So I think with that, for the chemical analysis, I could be like, I could kind of maybe make some educated guesses about what range we're going to find. For the microbiology piece, I don't have a clue yet.
It's still a mystery. to
Yeah.
us.
So it's kind of exciting, and I know even working with agriculture producers, I had somebody who sent their soil away to a lab, I think in California, and they sent me, and I think it was 50 pages long, of just scientific names of microbes, and they're like, does this mean anything to you? And I was like, no, it means nothing to me. I don't know what it is. And some of them they couldn't even identify. They're like, oh, we think it's this genus, but we don't know the species. And so I'm hoping that we can make some, because I know like one thing that might be interesting to look at is like the bacteria to fungi ratio and that type of thing are things people talk about in forestry, and so we might be looking at that kind of pieces, because we're also trying to take this information and make it usable. Like it's, sometimes you get numbers or a list of names and you're like, okay, this is great, but what now? So we're trying to make sure that this project tackles the what now, not just the what.
Right. Here's something interesting that I heard this morning, actually this noon hour. Fungi is, this was a Danish architect. Fungi is now being grown, and they're experimenting with it to use as building materials, because they've figured out that it will grow organically and it will grow on its own, and if it breaks, it will repair itself.
Yeah.
So they're molding it, and the idea is to make houses.
I just remember The Secret Life of Trees.
Yes.
If you've ever read that book or
Yes.
ever heard that book,
Yeah. Fungi are an interesting one. Every time I read something new about fungi, I'm like, that is like, they just kind of seem like magical a little bit.
It's just,
This is the world of the weevil. Come on.
well, when I was going to school here, one of my classmates actually did a project where she stuck some microbes in the soil and put an LED in there, and it gave off enough energy to light up the LED just from the soil, just from the microbes in the soil. It was incredible.
Yeah.
So
Yeah, they have now where they connect it, and then you can hear they connect it to music. You ever see those? It's
I think so.
where they will make sound from that energy, and then they use it from the.
I'm
It's
just-
a mystery. It's fascinating. Yeah.
If you wanted to put lights along a trail or something like that to guide through the night or whatever, like
Right.
if those microbes could be there and wouldn't,
Yeah.
Forget solar.
Solar and microbe,
you've got dark solar basically. It doesn't
Isn't it-
Yeah, I
require
mean,
light.
if they're working and they're giving off energy,
They
then.
might as well use it, like,
Yeah.
think about cleanliness, right?
So how deep do you take your soil samples?
So we're going to be taking soil samples based on the different horizons. So we classify it, so it's actually a good picture. You can see these little golf tees separate the different horizons. So the first one we'll be taking is the forest floor, so that'll just literally be like grab samples. And then what we want to target is the most chemically and biologically active horizons. So to give you an example, this like white-gray horizon that you see here is a leached horizon. So a lot of any like amorphous materials, so any of the carbon or nutrients that are there have been leached downwards. So this horizon right below it would actually be the more active horizon. So typically it would range between 10 and 25 centimeters is what we're targeting. But it'll change slightly depending on the ecosite, because some really rich sites won't have this leached layer. So we might sample that A horizon as well, whereas at this site we'd be sampling this B horizon. But typically we're sampling the forest floor once we remove all the litter, and then about 10 to 25 centimeters deep.
So did I misunderstand you? Did you say the leach area was the most active?
Least active.
Least active.
Least
Okay.
active, yeah, sorry. So the leach, so yeah, it's kind of stripped basically of all its color because all those nutrients like iron and stuff would often provides that red color to the soil. So if we sample this horizon there, there's not a whole lot going on in there because things have been leached downwards. So we want to make sure we're capturing, and we don't want to go too deep because we want to capture where the trees are going to be taking their nutrients up from. So in other projects that I've done, we have sampled kind of at 10 to 25 and then gone deeper than that as well. But for the purposes of this project, we're going to kind of 10 to 25 centimeters is what we're aiming for.
We're switching sessions
Okay.
now, so
I
I'm
think
gonna.
that was, yeah, the last thing was the project outcomes, but we kind of discussed some of this anyway, and these are just examples of how this soil, we could use the soil data, but we won't actually know any of this until we have it, so, yeah. I think that was everything. The only other thing, I'll just put this up there, so this is the website for the Center for Sustainable Management, is a QR code and also a website and contact information there for me, Debbie Reeves and Kevin Keys. If you have additional questions or anything, don't hesitate to reach out. This is my life for the next 4 years, so I'm happy to answer
Awesome.
questions.
Caitlin, you did a wonderful job
Thank you.
translating
Yes.
academic to actual English.
Thank you. Thank you so much for your questions. It was awesome. Yeah. No, that's one of the main goals of this project. So if any time you're
Well, you're successful.
yeah. Thank you.
Yeah.
Thank you.